part. In part 3, I'd just like to speak about medical, and that is the chemistry and toxicology of what happens when, like, let's say I vape this. When I vape that, exactly what happens. And then I'm also going to, well, first I'm going to give you some history as to what nicotine is all about. And then I'm going to tell you or explain the best to my ability, because I am definitely no doctor. I have no expertise whatsoever in this field, no experience whatsoever. In fact, most of these words I will have to spell out because, well, like I said, I have absolutely no experience whatsoever in the medical field. So just have to sort of bear with me. But why I'm doing this, and it'll be relatively a short video, a short part 3, is that I want to give you a little idea of where nicotine comes from, how it's extracted from the tobacco plant, and then as well as when you take the nicotine into your system, what happens when it processes throughout your body. So anyway, the first thing is called chemistry and toxicology. And let me make this a little larger so I can read it. In 1828, the chemist Posselt, that's Posselt, and Reimann of the University of Heidelberg, that's Heidelberg, isolated nicotine as the major pharmacoactive ingredient in tobacco. In 1895, Pinner, that's Pinner, established the chemical structure of nicotine as that of 3-1-methyl-2-pyrrolidinylpyridine. And that's actually in the FDA final rule. They actually speak to that, especially in the Tobacco Control Act, in fact, of 2009. Anyway, so tobacco belongs to the Solanaceae family, primarily two species, Nicotiana, Tabacum, and Nicotiana, Rustica, are used for the manufacture of chewing tobacco, oral and nasal snuff, cigarettes, cigars, and pipe tobacco. Most of the tobacco products manufactured in North America, Western Europe, and Africa are made of Nicotiana, Tabacum. Within the Nicotiana, Tabacum species, 4 types are commonly used. Bright from Virginia, Burley from Kentucky, Maryland, and Turkish Oriental tobaccos. Almost every part of the plant except the seed contains nicotine, but the concentration is related to different factors such as species, type of land, culture, and weather conditions. The concentration of nicotine increases with the age of the plant. Tobacco leaves contain 2 to 8% nicotine combined as malate or citrate. The distribution of the nicotine in the mature plant is widely variable. 64% of the total nicotine exists in the leaves, 18% in the stem, 13% in the root, and 5% in the flowers. All parts of the plant contain nicotine which can be extracted. The extract nicotine from tobacco leaves will be much more useful than in the form of cigarettes smoked. Nicotine is an alkaloid found in the nightshade family of plants, predominantly in tobacco and in lower quantities in tomato, eggplant, and in green pepper. Nicotine alkaloids are also found in the leaves of the cocoa plant. Nicotine constituents 0.3 to 5% of the tobacco plant by dry weight, with biosynthesis taking place in the roots and accumulate in the leaves. It is a potent neurotoxin. Nicotine is hygroscopic, orally liquid that is miscible with water in its base form. So that just gives you a little idea of what nicotine is. Okay, so it looks like 64% of the nicotine actually exists in the leaves alone, and there's 18% in the stem, and 13% in the root, and 5% in the flowers, and 0% in the seeds. So it just gives you a little idea of how the nicotine is, where it comes from, how much you can get from nicotine plants, and then who actually isolated nicotine, which was in 1828. So apparently they've been using nicotine for some time, since 1828. It's nothing new. Now, the next thing I want to get into is called inhalation and ingestion. So I'll just read it for what it says. Air coming in from the nose and the mouth reaches the back of the throat. Let me just make that a little larger once again. And enters an area known as the pharynx. The pharynx, that's P-H-A-R-Y-N-X, which is the entrance to the airways, divides into two tubes, one called the esophagus, which carries food to the stomach, and one called the trachea, which leads down towards the lungs. Contaminated air passes into the trachea, which itself divides into two large tubes, each called a bronchus. That's B-R-O-N-C-H-U-S. Each bronchus enters a lung. Once inside its lung, each bronchus starts to branch. The tubes of the bronchus get thinner and thinner as they spread, rather like the branches of a tree. Eventually, the tiniest tubes, which are called bronchioles, end in thin-walled air sacs. Each of these sacs is called an alveolus. Collectively, they are called alveoli, and there are many thousands of these in each lung. The walls of the alveoli, sorry about that, guys, alveoli are very thin and are richly supplied with tiny blood vessels, forget about pronouncing these words, capillaries. Waste carbon dioxide from the body carried in the blood inside the veins can pass out of the veins through the walls of the alveoli to become a part of the air which is exhaled. Oxygen in the inhaled breath crosses the alveolar walls to enter the blood within the capillaries. That's how you say it. Once oxygen has become attached to the blood inside the veins, it is then distributed throughout the body. Chemical vapors, gases, and mists which reach the alveoli in the lungs can also pass into the blood and be distributed around the body. Sometimes the concentration of chemicals reaching the alveolar air sacs is lower than in the workplace air. This is because the airways contain a lining of sticky, thick fluid called mucus. Tiny hairs, such as cilia, that's C-I-L-I-A, on the inside of the tubes constantly carry this mucus upwards toward the back of the throat. In some instances, a portion of the gases, vapors, and mists may be dissolved in this mucus before they reach the alveolar sacs. Solid visible particles found in dust, fumes, and smoke that have escaped the filtering mechanisms of the nose may also be trapped by the mucus. The mucus is wafted by the tiny cilia hairs until it reaches the back of the throat, where it is either expelled through the mouth or swallowed and passed to the stomach. In this latter case, the contaminating chemicals will enter the body in the same way as contaminated food or drink. Much smaller particles, so small that they cannot be seen by the eye, may not be stopped by the mucus in the trachea and bronchiole tubes. They travel through the various branches of the airway, eventually reach the alveoli. Solid particles which cannot pass through the thin wall of the air sacs may lodge and stay where they are. Some may dissolve, others may be attacked and destroyed by the scavenger cells of the body's defense system. Others may prove too big or too insoluble to be disposed of in this way and simply stay in their air sacs. Some of these particles, if they are present only in small quantities, do no apparent harm. Other types of dust may damage the surrounding alveolar walls. The damage may be permanent and may cause scars to form, which eventually interfere with the lungs' ability to pass oxygen into the bloodstream. Some acids, caustics, or organic chemicals, when inhaled in sizable amounts, can cause serious and irreparable burn damage to the mouth, nose, trachea, bronchi, and lungs. Chemicals which pass through the skin are nearly always in liquid form. Solid chemicals and gases or vapors do not generally pass through the skin unless they are first dissolved in moisture on the skin surface. Inhalation is the easiest and fastest means of exposure to toxic substances because toxic substances are readily absorbed in the respiratory tract. The lining of the respiratory tract is not effective in preventing absorption of toxic substances into the body. The respiratory tract consists of the nasal passages, the trachea or windpipe, the larynx, voice box, and the lungs. The following factors affect inhalation of toxic substances: concentration of toxic substance in the air, solubility of substance in the blood and tissue, respiration rate, length of exposure, condition of respiratory tract, and size of toxic particle. Almost over here. The rate or speed at which a toxic substance is removed from the body determines whether it will have a toxic effect. The longer a chemical is in the body, the greater the likelihood of damage. The main way a chemical is excreted from the human body is through the urine, but the kidneys, the lungs, and the liver are also important in removing certain chemicals from the body. The kidney eliminates the greatest number of toxins than any other tissue or organ. The lungs eliminate substances that are in the gaseous phase, like carbon dioxide. The liver removes substances like lead or DDT, pesticide, by excreting them into bile, which is made by the liver and travels to the small intestine. From there, the substance can be absorbed in the feces and eliminated through excretion. Neither the sweat glands nor the GI tract are important routes for excreting of 103 toxic substances. Skin, hair, and breast milk are pathways, although minor, for excretion. All people are not equally sensitive to chemicals and are not affected by them in the same way. There are many reasons for this. People's bodies vary in their ability to break down or eliminate certain chemicals due to genetic differences. People may become allergic to a chemical after being exposed. Then they may react to very low levels of the chemical and have different or more serious health effects than non-allergic people exposed to the same amount. People who are allergic to bee venom, for example, have a more serious reaction to a bee sting than people who are not allergic. Factors such as age, illness, diet, alcohol use, pregnancy, and medical or non-medical drug use can also affect a person's sensitivity to a chemical. Young kids are often more sensitive to chemicals for a number of reasons. Their bodies are still developing, and they cannot get rid of some chemicals as well as adults. Also, kids absorb greater amounts of some chemicals, such as lead, into their blood than adults. Cancer is an example of a delayed health effect. Cancer is the uncontrolled growth and spread of abnormal cells in the body. There are many kinds of cancer. Cancer can be caused by a number of things, including exposure to toxic substances, ultraviolet sunlight, and ionizing radiation. Exposure to some chemicals such as benzene and asbestos can produce cancer in humans. Some chemicals produce cancer in animals, but whether they will in humans is unknown. Because cancer may not appear until 5 to 40 years after exposure, determining the cause of cancer is difficult. So that gives you somewhat of an understanding of, like, when I vape this thing. Let me put a little of this in here. A little in my Velocity RDA. When I vape this thing here, this particular vape actually affects me differently than someone else. It depends. Like for instance, I smoked cigarettes, analog cigarettes, from the age I was 17 until I was 52 years old. And I'd say I had smoked about a pack, maybe a pack and a half a day, depending upon what I was doing. If I was driving in the car a lot, then I smoked even more for some strange reason. I always smoked more in the car. If I was at home or on the computer or something, I smoked more that way as well. If I'm just watching TV or something, usually I don't smoke as much. Kind of strange. Read a book, I didn't smoke so much either. Also, I took up cigars, very expensive cigars. Ashton cigars was my favorite. They cost me a bunch of money during some years there, especially in my 40s, and then I stopped at the age of 52. And that also was more of a very reflective type of smoke. So I would mainly do cigars when I'm reading or writing something or something like that. But what my point is those analog cigarettes, all those years probably affected me much differently than somebody else. And it also, like it says, is due to your genetics as well. Look at George Burns. He smoked cigars till he was like 100 years old. And I'll tell you another thing. Einstein smoked pipe tobacco, and he's a genius. And the FDA will say, well, and I actually speak to that actually in the FDA final rule, that they say that there's the fetal development is stunted to a degree because of vaping products or analog cigarettes or whatever have you, when in fact here you have Albert Einstein, that was a genius. He had like an IQ of like 160, 180 or whatever, and he smoked pipe tobacco all his life. And I'll go you one better. His grandfather smoked cigars. Apparently, his grandfather smoking cigars did not damage the bloodline or the genetics until, all the way through to Albert Einstein, which, by the way, is a genius. So it varies, is what it is. And so when I eventually do read about the FDA final rule, they can't really say that, make a blanket statement, a generalized statement, and say everyone will be affected this way because of vaping. No. Everyone, I don't care who you are. I think it's 323 million Americans in America. If they all vaped, they would all react differently to the vaping. The one thing that's guaranteed, at least so far by studies that have been done, is that there was one vape study, I think it was the Oxford College, that says that it's 95% less harmful than analog cigarettes. And there's other studies out there that pretty much state the same thing. Overall, how it affects overall, as far as the population is concerned, is that it's less harmful than analog cigarettes. And the reason why that is because in analog cigarettes, it's the combustion that makes all those compounds of all those chemicals. When that tobacco plant is dried and cured, and then it's cured with all kinds of other chemicals and different tastes and flavorings and all that other stuff, they turn into different types of chemicals and compounds within that drying process. Let alone when you actually smoke the cigarette, that combustion itself creates over 4,000 chemicals and compounds. So, which are very highly toxic to the point of that it kills 400,000 Americans every year. And that's just in America. I'm not talking about around the world. So, but why I did this little part here is so you can understand about where nicotine came from, who discovered it, or let's say who extracted it from tobacco in 1828, and then also what happens, how your body responds to certain chemicals that enter it. Like I said, everybody's body is different, absolutely. And for the FDA to make a blanket generalized statement that vaping is bad for you or doesn't promote public health in a generalized manner is completely wrong. It's completely, what's the word for it? It's just completely misinformation is what it is. Absolute misinformation. It's no basis in no factual basis whatsoever. So that's why I wanted to do this little part here, and then now I'm going to move on to part 4. That's it for this one. Bye.